Hey guys, in this video I'm going to show you how to solve a problem where your file system is out of space and you've deleted the file that was using up that space rather than truncating the file, and the disk space has not been freed up. So this can happen when the file is being held open by a running process. So if a running process has the file handle to this file open, that would happen if it's either reading from that file or writing to that file, then that space will not be cleared until that process either closes the file handle or that process is stopped. So you could restart the process and that would be a quick fix. Once you restart the process, it's going to free up the disk space. But we're imagining a scenario where you can't terminate the process because it's an important process. For example, it's a really business critical process that can't be restarted under any circumstances, but you still need to clear out that disk space. So I'm going to show you how to avoid this problem, and I'm going to show you how to fix this problem if you do run into this. In this example, we're going to be using Nginx as the service, but it doesn't have to be Nginx. It could be like a custom-built server or any random server or service that might behave in a different way. So in any case, let's take a look at our system over here. We are logged in as root. Now if we say df-h dot and hit enter, we see we have our disk is used up 100%. So we can take a look. I already know which file is using up this space because this is an example, so we don't have to search around too much. We can run du-sh var log nginx error.log, and you can see this log file is using up 3.7 gigs out of an 8 gig drive. So if we were to clear this log file, we would basically clear a whole lot of space, right? So we on this file we can run lsof. Now we already know this is held open by nginx, but we're just going to check it just to show you how you would do that. lsof, for example, if this were some random data file being held open by a process and you don't know which process it is, it would be useful to know how to do this. So you can run lsof and it will show you two different processes. You can see this is the same PID for these two and the same PID for these two. So two processes, but 4 file handles, all for the same file. Now, so that's what's using that file. So let's see here. Let's say if we decided to rm the file, just run rm to delete the file. And now we can run ls to verify that the file has in fact been deleted. Now if we run df-h dot again, we see no disk space has been freed up. So that did not clear up any space. So that's a problem right there. Now what we should have done is instead of running rm, what we should have done was say echo greater than sign, just one single greater than sign, and this will echo an empty string over the file, replacing all the contents of the file with an empty string. This basically truncates the file, and it clears up all the space that was used by the file, removing all the contents of the file without actually deleting it. And when you clear the contents of the file, that will clear up the space used by the file, regardless of whether or not any processes are started or stopped. However, if you were to remove the file instead, the space used by the file doesn't actually get freed up until any process using that file is stopped or closes the file. So right now it's too late to truncate the file, and if we did attempt to truncate the file, it wouldn't do anything because we'd be writing to a new file, not the file that we deleted. So before I go any further, I'm just going to show you pscf rep nginx, and these are our nginx processes that are running, just to show you. So we have 2 of them there. So there is a way, so assuming you've already deleted the file and it's too late to truncate the file, so truncating the file would be the way you can avoid getting in this situation to begin with. But let's say you've already deleted the file, and I'm going to show you how you can fix this. So you can actually check in the proc file system, and if you do a find on the proc file system, right here is where you'd specify the PID of any process you want to look into. So we're going to use a wildcard just to show all processes, and we're going to show the file descriptors for all processes. And for each of these file descriptors, we're going to run ls, which is going to basically just give us the full path for each of those files, for each of those file descriptors in the proc file system. And then we're going to pipe it to grep, and grep for the string deleted. So that is going to show us any files that have been deleted, you're going to see an entry here. So if you still have a file handle open, but the file has been deleted, it's going to be shown here. Now, the other thing you can do is, let's say if you had a lot of these from different processes and you wanted to narrow it down to the application that you're looking at, let's say, for example, Nginx in this case, you could grep for Nginx. Now, we don't need to do that in this case, but this could be useful in more complicated situations. So the next thing you're going to want to do, basically what you could do, all you really need to do is truncate each one of these file descriptors. Use the truncate command I showed you before. Rather than truncating each of these file descriptors one at a time, we're going to use the we're basically we're going to use this in a for loop. So before we can do that, we're going to have to we're basically going to get a list of each of these file handles. So what we're going to do is we're going to pipe this to awk like this. So pipe this to awk print $12. Now you're going to have to, 12 is going to be the column. Now you're going to want to pay attention to the columns because depending on like the names of your files and stuff like that, it could be a different column, so pay attention to what you're doing before you actually run this. So first we're going to see here we're getting the wrong column, so we're going to change this to 11. So 11 will give us a list of file descriptors that we're interested in. And once you've done that, you can use this in a for loop. So for example, let's see here. I'm going to paste this right in here. And this is a for loop, basically using this exact same command that we have here that lists the file descriptors. We're going to use that list of file descriptors and we're going to put it in backticks, so we use it as a list that our for loop can loop over. So we say for I in, then find, and run that whole command that gives you that list. And then you say do echo, and we're going to echo out an empty string over $I, which will be that file descriptor. So this basically echoes an empty string over each one of these file descriptors, basically truncating each one of these file descriptors. And so what we're going to do is we're going to just say enter, and there we go, we ran it. Now if we say df-h dot, we see our file system has been, the space has been cleared up and our file system usage is down to 58%, which is what it should be because we basically truncated that log file. Now, we still have a problem here because at least this fixes the main issue, but there's still a problem that the log file that this process is supposed to be writing to is now not accessible. So, if you wanted to check for error messages, basically our Nginx server is still writing to that log file. It actually probably isn't writing anywhere. So you still want to restart the server eventually, but this will clear up the disk space and keep the process running for the time being. So this is a good solution if this is a situation that you find yourself in. But if you take a look here, you'll see that log file still doesn't exist, so you now don't have a log file you're still in a better situation than you were when the disk space is at 100%, because in that case you still can't, nothing is getting logged to the log file anyways, but you're still in a situation where now you can't see any of your errors that are coming from your Nginx service. You're still going to be safe. This is the type of situation where you could wait until like a maintenance window or a safe time to actually restart the process. So to really fix this, you could just restart Nginx. So say, for example, systemctl restart Nginx, and there we go. We restarted Nginx, and we see now our error log has been recreated, and our disk space is still at 58%. So that's really what you'd want to do when you finally have time for a maintenance window. But this fix will basically buy you some time, so you could wait until a safe time to actually restart the process without disrupting any business processes or anything like that. So hopefully you found this useful. Give me a thumbs up. Definitely going to want to subscribe. Hit that subscribe button, hit the little bell icon, and if you know something I don't know, leave a comment down below. Any comments, questions, criticisms, leave a comment down below. Hopefully you found this useful. If not useful, at least interesting. And as always, thanks for watching, and we'll see you guys on that next video.